Okay, last video left off with me filling in this blank here, and now we're going to practice some problems where we are raising a power to a power, okay? Remember that requires you to keep the base and multiply the exponents. So we'll keep our base of 8, multiply 8 times 4, and get 32. On this next one, it's keeping your base of n, multiplying 3 times 7 to get 21. On the next one, keep your base of negative h. And then the power to the power, the 4 times 5 would be to the 20th power. Keep your base of m. 2 times 5 would be to the 10th power on that one, okay? Next one here, 4x to the third, okay? So both of those things, the 4 and the x, are being raised to the third power, okay? So this doesn't involve a power to a power. This is just basically raising this 4x to the third power, and we are going to simplify that. Okay, so know that it's 4 to the third times x to the third, and you can do parentheses around that, whatever you so please. Anyways, 4 to the third is 4 times 4 times 4, which is 64, followed by your x to the third, okay? Similar situation here. You've got both of these things needing to be raised to the fourth power. 1/2 to the fourth power, u to the fourth power. So 1/2 times 1/2 times 1/2 times 1/2. So basically the 2's in the denominator are getting multiplied. 1 times 1 times 1 is just 1. So you've got 1 to the fourth and 2 to the fourth is kind of what I'm trying to explain there. So 1 times 1 times 1 times 1 is 1. And then 2 to the fourth, 2 times 2 times 2 times 2 is where I'm getting the 16. And then followed by u to the fourth. Here we do have a little bit of a power to a power with the 4 and the 5 here. And we are going to have 2 to the fifth. And then w, power to a power, 4 times 5 is going to be to the 20th power, okay? Well, 2 to the fifth, you can, do it out long ways, put it in your calculator, whatever you so please. It's going to be 32. So 32w to the 20th power. We're just going to have this 2 kind of hanging out here. Everything you see in these parentheses is going to be squared. In other words, raised to the second power. So then you're going to go with 8 squared. And then m to the fourth, when you square that, you're going to get m to the 8th, n squared. Do you want to think about this guy having a 1 right now? 1 times 2 is where I'm going to be getting that 2, okay? I'm going to go ahead and square the 8 and get your 64. I'm sorry, it'd help if I wrote the right thing. I'm going to get the 64 there, m to the 8th n squared. And then 2 times 64 will give me 128 m to the 8th n squared. All right, here you have a fraction, 4/5 being raised to the third power. So we want to be sure and cube both numerator and denominator. So 4 times 4 times 4 will give me 64. 5 times 5 times 5 will be 125. 6 squared over x squared will be 36 over x squared. M squared raised to the fourth power, power to a power, will give you m to the 8th. And v cubed raised to the fourth power will be v to the 12th. T squared, you're cubing that, so you'll get t to the 6th. Again, if you want to think about the 1 being here, power to a power, 1 times 3 is 3. That'll be z cubed. Okay. Next page, we're going to be looking at when you have a product, so when you multiply, and you've got some power rules going on here. Okay, so I know it's really light to see, but this is kind of summarizing our basic power. Oh, you can't say it. Your basic power to a power. The deal that we just did, where when you have something like this, you're going to add those. You're going to multiply a power to a power. You're going to multiply. So, say you had a to the third, and you're going to raise that to the 7th. You're going to get a to the 21st power. The next thing that you can see here very vaguely, power rule for a product, okay? So what's going on there is you've got, again, something we just saw where you had, say, 5x that was all raised to the third power. Each of those things has to get raised to the third power. So again, we saw some of those a second ago, okay? And quotient, we also saw, if I'm not mistaken, like the fraction, like 2/5 or whatever we saw a second ago, getting, say, squared. That needs to be 2 squared over 5 squared, which is 4 over 25. So just knowing basically that if you've got parentheses around it, everything needs to be taken to whatever that power is, okay? So combining these rules, it says when combining the product and power rules, always follow the order of operations. Meaning, you know, do your parentheses first, your exponents. So we will have an order that we need to do, okay? All right. So up first, we've got this quantity getting squared and this quantity getting cubed. So you're going to see me take each of these individual terms to the power that we need to, okay? So 4 squared, f squared, 2 cubed, f cubed. 4 squared is 16, of course, 4 times 4. 2 cubed, 2 times 2 times 2 is 8, f cubed. Still with a couple different things here, and we can actually go ahead and multiply these guys together. 16 times 8 is 128. F squared times f cubed. That takes us back to adding those exponents when we're just multiplying. So 2 plus 3 will be f to the 5th. What you're going to see here is similar. I think we saw it a second ago a little bit. Just kind of hang out for a little bit with that -3. Everything you see here is going to get taken to the third power, okay? So you're going to see me do 4 cubed. Now a squared taken to the third power. You multiply a power to a power, and you're going to get a to the 6th. B to the 4th taken to the third power. You multiply a power to a power and get b to the 12th. 4 cubed, I think it was 8 squared we had to do a minute ago before distributing 2. But anyway, 4 cubed, 4 times 4 times 4 is 64. And then I will distribute my -3, kind of like I did on the earlier problem. So -3 times 64 is a -192. A to the 6th, b to the 12th. This one here, you're going to see me again taking everything in those exponents to the second power, everything in the parentheses to that exponent, everything in those parentheses to that exponent. So you'll see me with 12 squared. 3 times 2 is y to the 6th. 4 cubed, z to the 10th raised to the third power. So 10 times 3 is going to be z to the 30th power. 12 squared, 12 times 12 is 144. Y to the 6th, 4 cubed, of course, is 4 times 4 times 4, which is 64. And then these guys here, they're both even, so they at least, divide by 2. But if you go and simplify them all the way down, you get down to 9/4, and there's no simplification with these variables here, because, of course, they're different variables, okay? So 9/4, and then you got your y to the 6th, z to the 30th. Over here, if you want to think about this negative sign right here as just like a -1 basically in front of this, okay? This even power out here is important because say you've got, well, let's say -1 to the 4th. -1 times -1 times -1 times -1. It's even, so it's going to result in a positive number because a negative times a negative is a positive, then it turns negative, then it turns positive again. So that's where you're going to basically see this negative turn into a positive, and we don't have to really worry about it anymore. We'll put our positive sign out there just so that we know we have dealt with that negative sign. We have raised to the 4th power. We haven't forgotten about it. But you're going to see me take everything, numerator and denominator, to the 4th power, okay? So 3 to the 4th. T to the 4th raised to the 4th will be t to the 16th, u to the 9th. 9 times 4 is u to the 36th power. And we've got your 2 to the 4th. V squared raised to the 4th power will be v to the 8th, okay? 3 to the 4th, of course, is 3 times 3 times 3 times 3, so I'm going to get 81. Still t to the 16th, u to the 36th. 2 to the 4th is going to give me 16. V to the 8th. No simplification with these variables yet, so that's as simple as we can go. Alrighty, moving right along. This page here is titled Keep on Practicing. So I will leave it for you guys to work through kind of on your own if you have time, want to, whatnot. I may go over it in the video Blackboard Collaborate, but I won't work through it here. It's just kind of a little bit more practice, okay? All right. Up next, we have 0 as an exponent that we're going to talk about, okay? This is something that's kind of easy to forget about in the middle of all the exponent stuff. But a base that is 0 with an exponent that is 0 is equal to 0. So that's like 0 to the 0 power. Well, that's 0. However, that 0 power operates differently when you have a base that's not 0. It says any base that is not 0 with an exponent that is 0 is equal to 1. So this is a lengthy list, right? 5 to the 0 is 1. 8 to the 0 is 1, okay? So anything, almost anything to the 0 power is going to give you 1, okay? So we're going to sashay through these examples here using the things that we know, including this, to get some answers here, okay? So this would be an example of 3 to the 0. This is a base that is not 0 being raised to 0 power, so we'll give us 1. 0 to 0, however, is 0. And this, again, is a base that is not 0. Being raised to the 0 power should give us 1. Here you've got 4 minus 2 squared, which is 4. So we do want to recognize that 4 minus 4 is 0, right? So this is an example of 0 to 0 power. Well, we know that is going to be 0. You've got a 3 out here just kind of hanging out, but he's being multiplied by 3 to the 0 power. Well, this is an example of a situation where this base raised to the 0 power is going to give you 1, because just about anything raised to the 0 power will be 1, except, of course, 0 to the 0 power. So anyway, 3 times 1 is 3. This right here is, notice kind of the similarities but the differences here, okay? You've got a negative sign just hanging out. And then you've got 9 to the 0 power. Well, 9 to 0 power is 1, so this results in a negative 1. Different situation here. They're raising negative 9 to the 0 power. So this entire thing to the 0 power will actually give you the positive 1 that we've been seeing show up, because when you raise anything to the 0 power, except 0 that is, you're going to get 1. This is some variable to the 0 power, and it says assume the variables are not zeros. So assuming k is not 0, this should give you 1. Here's another example of raising something to the 0 power. It gives me 1. Here you've got a negative 3 just hanging out. This reminds me of kind of like that one right there. R to the 0 power is where I'm going to get 1. So negative 3 times 1 will be negative 3. X to the 0 power, since we know these variables are not equal to 0, that'll give me 1. And this to the 0 power will also give me 1. So 1 plus 1 will be 2. Now we're going to look, approaching that 13-minute mark that I need to stop at because it takes a long time to upload. So let me get through these examples down here. When you have a negative integer, you simplify by taking the reciprocal of the base and then make the exponent positive. So reciprocals work this way. If you have 1 over 3, the reciprocal is 3 over 1. If you have 7, which is like 7 over 1, the reciprocal is 1 over 7. So sometimes we say the word flip when we talk about the reciprocal. So we're simply going to flip it and make the exponent positive, okay? So sashaying down here, this is essentially 3 over 1 raised to the negative 3 power. So flip it, make the exponent positive. Flip it, find the reciprocal, I should be saying, make the exponent positive. Reciprocal and positive, and that could be just 3 to the 4th. As well, that one, this was the answer that it ended up being. So I'm going to go back and make sure I have the right one circled for y'all. This is essentially, it's got the negative just kind of hanging out is really what's happening, but it does need to stay there, okay? So think about it as negative 2 over 1. So we'll flip this, make it negative 1 over 2. And then if you make your exponent positive in the process of flipping it, your exponent will be a positive 2. Okay. And you can simplify that further if you want, as you could have done, I guess, all of these, right? If you're cubing this one, it's 1 cubed, which is 1. 3 cubed is 27. 5 squared is 25. 4 squared is 16. This guy, I never took him all the way down, but 3 to the 4, 3 times 3 times 3 times 3 is 81. And what you're doing here, because there wasn't parentheses around this guy, There are 1 parentheses around him in the answer. So you're squaring him and making him 1 over 4 because 1 squared and 2 squared. But then you've got that negative hanging out. So you actually get a negative 1/4. Okay, so I'm going to stop this video and upload it because it does take a while. And I do have some more examples to go through after this. So just a couple more pages, I guess.